Good evening, everyone. Am I audible? Can you hear me? Is my voice audible? Okay, fine. Okay. So, in today's session, we will be revising week 1 and week 2. Okay. And week 3 and week 4 will be revised in another session in next week. Okay. So, today mainly we are going to concentrate on week 1 and 2. Okay. So, we'll start with topics from week 1. Okay. All right. We'll quickly revise all the topics. Okay, so here the first topic we are having is few basic definitions. So the part of statistics concerned with the description and summarization of sorry description and summarization of the data is the descriptive statistics, right? So in descriptive statistics we do like summarization, doing graphs, finding some measures of central tendency, measures of variation, and all that. And then in inferential statistics is the part of statistics concerned with drawing of conclusions from the data, right? Suppose we are drawing some conclusions about the given data, which is a sample, and we are inferring something for a much bigger set, okay? Or we are going to infer something for the future, okay? So this part is called the inferential statistics, okay? And suppose we are interested in knowing, for example, here the percent of all students in India who have passed their class 12 exams and study engineering. Okay. So in this case, we won't be able to look at all students who are studying class 12, right? So in that case, what we will do, we will collect a sample from each state, let us say. Okay. From each state, we will collect a sample of 100 students and we will see 100 students who study engineering, right? So those percentage we will collect as a sample. We will not be able to do the collection, the data, collect the data for all students who have passed class 12, right? Similarly, for example, the prices of all houses in Tamil Nadu. This might be a difficult thing to do, right? So instead of doing so, here, for example, in this case, what should be the population, the prices of all houses in Tamil Nadu for this study? So the population here, for example, if we are consider here, the population is all houses in Tamil Nadu, right? And what should be, for example, we can consider, for example, 1,000 houses in each district.
Excuse me, ma'am.
Yes.
Ma'am, I'm really sorry for interrupting, ma'am, but this session link was not shown in our calendar. I just joined by checking on YouTube that the session was live streaming. I did not see the link of this session in my calendar.
Is it the same for everyone?
Yes, ma'am.
I saw
Yes,
the
ma'am.
link in my calendar.
Today is not for the calendar.
Sorry, it was not available in your calendar.
Yes, ma'am.
Ma'am,
I have
instead
joined
of
by
this class,
another date. Hello, ma'am. I have joined this class. I have joined this class by another date.
Okay, just let
only
me.
CT class is shown. No quiz
It's
one
on
revision session
7
is shown.
But you
July.
all received a mail, right?
Ma'am, we have received the mail, but today in our calendar, today there's no link given. I
Yeah.
joined.
Okay, just give me a minute. I will
I
check
joined
the
that
calendar so that the other students who
by.
wants to join will not miss the session. Just give me a minute, okay? I'll see
Yes,
what.
ma'am. That's why students are guessing with this, ma'am.
Yeah, I'll just check once.
Hi, hello.
Now is it visible? Can you please
Yes,
check
ma'am.
your calendars? Okay, sorry.
Yes, ma'am.
Actually, I have scheduled it, but I guess I did not click this May 26th term. So that was the issue. Sorry.
Yes, ma'am.
Okay, so let's continue. I hope some other students will also join. All right. So where were we? Yeah. So here, for example, here you see that the population here is all houses in Tamil Nadu. And for example, sample in this case, we can consider.
Ma'am, can we take from starting?
Yeah.
Can we take from the start?
Why?
Now when I joined, ma'am, I don't get it link.
I did not discuss much. I just gave the definition of descriptive and inferential statistics. I did not do much. Okay.
Okay, ma'am.
Yeah. Okay. So now in the next case, the total sales of all cars in India in the year 2029. In this case, what is the population? Can you tell me?
All the cars sold in India.
Yeah. All cars sold in India, particularly in 2019. Right? What can be a representative sample? Let's say cars sold in capital cities in each state.
In 2019.
In 2019. Okay. All right.
Yes.
So you know what is a population and a sample when you are having a statistical study, right? Okay. So what is meant by population? Population here is the total collection of all the elements that we are interested in. And what is a sample? Sample is a subgroup of the population that will be studied in detail. Okay. So let us look at this exercise. Can you all quickly look at this exercise and see what is the answer for this? Which one of the following statement best describes the difference between population and sample? Sample is the entire
Ma'am,
group.
option number third.
C.
Option C.
Third one, ma'am.
C.
Yeah.
Option
So
number C,
Third
ma'am.
one, ma'am.
yeah. So population is the entire group, while sample is a subset of the population, which is used to describe the parameters of the population. Right? So here, what is the mistake in the last one? So it is not about who volunteers. So it is not necessarily. Right? So this is not necessarily true. Okay, fine. Okay, what about the next exercise? According to a university rule, the average weight of a standard library book should not exceed 800 grams. The library management suspects that the average weight of books in their library is more than 800 grams. To verify this, 120 books were randomly selected from the library and their weights were measured. Based on this, choose the correct option from below.
Option B, ma'am.
Option B.
Option B.
Option B, ma'am.
Is
B.
all library books
Ma'am,
and
option number B.
yeah, very good. Okay. So the next thing is that we know any given data can be classified either as categorical or numerical, right? So categorical, the other name is qualitative variables, and for numerical, the other word is quantitative variables. Okay, categorical data, we have to identify which group it belongs to, and numerical data, it is based on the numerical properties, right? So for example, Numerical data have measurements, right? So measurement units, scale that defines the meaning of numerical data, such as weights measured in kilograms, prices in rupees, heights in centimeters. These are all numerical data, right? The data that make up a numerical variable in a data table must share a common unit. Remember that, suppose let us say you are collecting the weight of a group of people. You cannot collect weight in kilograms, pounds, and different units you cannot follow. You should follow the same unit for all the data, right? This is something very important. Cross-sectional and time series data. Cross-sectional and time series data. Time series data recorded over time. So time series data is the data recorded over time. In the sense, can you give some examples for a time series data? Anyone?
The rate of monsoon in Mumbai from 2021 to 2022.
Yeah. So over a period, you are collecting the same variable. Yes. So here for representing the time series data, a time plot is used. Graph of a time series showing values in a chronological order, right? So for example, you can see usually, so for example, suppose we want to look at,
Ma'am, one example is also.
yeah, tell me.
Ma'am, change in expenditure from the year 1995 to 2007. Hello, ma'am. Ma'am, hello.
Ma'am was muted. Wait.
Yes, sorry for the interruption. Yep, you were saying something. Yes, please continue.
Yes, ma'am. Ma'am, change in expenditure from the year 1997 to 2007.
Yes, correct. Yeah, so you whatever you are recording, if you are recording the same variable but over a period of time, then that is an example. Yes, correct. So for example, if you are looking at
Ma'am.
sales, yes.
At one time, how much data we can record in time series?
Sorry, what?
Ma'am, can we record multiple data over time?
Multiple data over time. So if you are going to record, for example, let us say what is the electricity consumption and what is the, so let's say the electricity bill. So yeah, you can collect these two data over a period of time. Let us say over different periods of the same year. So over different months, what is the electricity consumption as well as the electricity bill? Yes, that is also a time series data only. Okay, so for example, sales of ice cream here I'm saying. So here, for example, this is over different seasons. Okay, so let us say this is over winter, spring, and then you have summer. So like this, you are doing over different periods. Okay, so then let us say this is for 2024. Similarly, you can do for 2025, 2026, and so on. Okay, so like this, if you are doing, so usually in winter, the sales is going to be down. And then when you are reaching summer, it's going to reach a peak, right? The same pattern you can see in every year, right? So again, you will see in winter, there is going to be a fall. Then summer, it may increase. And then the same pattern is going to continue every year. So time series pattern helps us to observe patterns. Okay, so this is the use of having a time series data to see if there is any pattern over a period of time. Okay. All right.
Hey, ma'am.
Yes.
Ma'am, I had a doubt from this time series graph only.
If there are specific questions, maybe we will keep that at the end of the session. So revision session, we will try to cover all the topics first and then the doubts at the end. Okay.
No, ma'am, it's not a doubt like that. I'm asking, like, you told us for example, the electricity consumption and the bill, right?
Yeah.
For example, we have water bill and electricity bill, and we have to make a time series data graph. So wouldn't that have two graphs plotted on the same graph paper?
Yeah, that is also possible, but provided, see, the thing is that when you are making a time plot, your y-axis should represent the same type of data only. It cannot give us different type of data. So time plot cannot give the representation of two different variables, right? Because y-axis, suppose if it is representing rupees, it cannot represent watts, right? So in that case, time plot, what is the y-axis? If that is common for two different variables you are using, then it's fine. Otherwise, you cannot use the same time plot.
Okay, ma'am. Then for the water bill, electricity bill, it'll be possible because y-axis would be
In
the.
that case, it is possible, yes.
Okay, ठीक है, ma'am.
Yeah. Okay. Cross-sectional data is data observed at the same time in multiple places, right? So for example, here you see that a public health researcher collects data on the number of COVID-19 cases in 20 different districts of Tamil Nadu on March 1, 2021. Right? So here what happens, each district's COVID-19 case count is recorded on the same date. So different district we are collecting, but on the same date. Right? So here the main thing is that we are collecting data from different districts at one point of time. Okay, so this is an example of a cross-sectional data time series over a period, cross-sectional at one point of time. Similarly, look at the second example. So the second example, a company records its monthly electricity consumption from Jan 22 to 2022 to December 2025. So now here you see this is now over a period, right? Over a period. If it is over a period, we already know it should not be cross-sectional, it is time series, right? Data is collected over multiple time periods. It tracks the same variable. The electricity consumption is tracked over period. So now the first example you see is an example of cross-sectional data, and the second example is an example of a time series data. Is this clear? Okay.
Yes, ma'am.
Yes, ma'am.
Yes.
Yes, ma'am.
Okay. So the next thing is here we are going to look at scales of measurement. So what are the different scales of measurement? We know they are nominal, ordinal, interval, and ratio. Right? So what is nominal scale of measurement? When the data for a variable consists of labels or names used to identify the characteristic of an observation, the scale of measurement is considered as a nominal scale. For example, name, which board of school, gender, blood group, all these comes under nominal category, right? So this is something very important. Sometimes numerical variable, sometimes you see numerical numbers you can see which are representing nominal variables. We might, for example, see code men as 1 and women as 2, or code men as 3 and women as 1, right? So these kind of codes are not implying any numerical value of what is behind that. They are just some representation. So in that case, again, they are just numerical, nominal values only. Okay. So nominal values are name categories without implying any order. Similarly, as I have mentioned in the live session, so you can instruct the usual weekly live session. So for example, you see this, what is called this, players, for example, in cricket players or any other sports team, that they have some numbers in their t-shirts and all, right? So these numbers in the t-shirt, they do not really imply any meaning to the player, right? So they are just numbers representing them, right? So they are again nominal only. Similarly, ID numbers, register numbers, all these things comes under nominal category, right? Okay. Next thing is ordinal scale of measurement. What is ordinal scale of measurement? Data exhibits properties of nominal data and the order or rank of data is meaningful. So just one step, more than nominal. In nominal, whatever we are having, the same we are having in ordinal. But then here we are having some order or rank of the data, right? For example, if we are looking at the customer's service rating, we can classify them as excellent, good, or poor. In that case, you see we have some order here, right? So this now becomes an ordinal data. Okay, so with respect to quality, we can order them, and hence this now becomes an ordinal data. Okay, fine. And then the next category is about interval scale. Okay, so first two categories, what we have seen, the first two categories are nominal and ordinal. Nominal and ordinal both are categorical or numerical?
Categorical.
Categorical.
Okay, so then interval and ratio both comes under numerical, right? And interval, if the data have all the properties of ordinal data and the interval between values is expressed in terms of a fixed unit of measure, then the scale of measurement is interval scale. So intervals are first of all always numeric. Okay, we can find out the difference between any two values. But one thing here, the ratio of values have no meaning here. Okay, so here there is no true zero. So what is absolute zero is not very clear in this case of interval, right? So for example, suppose the response to a question on how hot the day is, how hot the day is, comfortable and uncomfortable, then the temperature as a variable is nominal. Okay, so in this case, the responsible is just saying comfortable, uncomfortable. So it is just a nominal variable. Now, suppose the answer to measuring the temperature of a liquid is cold, warm, and hot. So it's kind of having an order. So now becomes ordinal. Now the same, if you are measuring the exact degree Celsius value, it becomes a interval scale, right? Consider a AC room where temperature is set at 20 degrees Celsius and the temperature outside the room is 40 degrees Celsius. It is correct to say that the difference in temperature is 20. So you see that difference is making sense, right? But it is incorrect to say that outdoors is twice as hot as indoors. So this means ratio is not making sense. Right? This is what is ratio, right? So ratio is not making sense here. Okay. So in this case, that is why this is coming as an interval value. And again, the important thing is here there is no absolute zero. What is meant by no absolute zero? So for example, 0 degrees Celsius does not say there is no temperature at all. Okay, so 0 degrees Celsius is just a freezing point of water. Okay, so that scale we are calling as Celsius. That's it. Okay, so here there is no absolute zero for Celsius or Fahrenheit use. Okay, and what about ratio scale of measurement? For ratio scale of measurement, of course, difference as well as the ratio both make sense and it has an absolute zero. Okay, so here you see that it can be added, subtracted, multiplied, or divided. Okay, so here comparisons in terms of ratio are possible. So here is a quick exercise. Can you all do this one?
Yes, ma'am.
So which is nominal?
Blood group. Option 2.
Blood group.
Blood group.
Ordinal?
Blood group, ma'am.
Third one.
Means rank of students.
Rank of students.
Option number 3.
3.
Interval?
1.
Weight.
Ma'am, 1.
Temperature in degrees Celsius.
Ratio.
Ratio weight of a person.
Temperature and lady.
Okay. So quick glance again. So ratio scale means true zero exists and ratios are possible. And interval scale, no absolute zero, but difference exists. And note that these two are numerical data. Okay. And then ordinal and nominal, these two are categorical data. Okay. So ordinal, you have an ordered category. Nominal, there is no order. Okay. Fine. Okay. So now moving to week 2 contents. So what are there in week 2? Okay. So again, starting with some simple exercises. What kind of variables are comparative forms of adverbs like more, less, good, better, and best?
Categorical.
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 Okay. What kind of variable is the qualification of a candidate sitting for an interview?
Numerical.
Categorical.
Categorical.
Okay.
Yeah. Oh, okay. Fine. So we know what are categorical data. So now for categorical data, there are few things we are going to see. Okay. So first we will see what is a frequency distribution. A frequency distribution of qualitative data is a listing of the data values and their frequencies. Okay. So here each row of a frequency table lists a category along with the number of cases in this category. For example, here, look at this data given here. So the following data represent the shoe sizes purchased at the shoe store on a particular day. So what are the distinct values you see here?
5, 6, 7, 8, 9.
5, 6, 7, 8, 9.
8, 9.
Okay. Now how many fives are there? 1,
2.
2. Right? So only 2 fives are there. So in that case, yeah. And what about 6? 1, 2, 3,
4.
4. Okay. What about 7?
4.
4.
2, 3, 4. Okay. What about 8?
6.
6.
1, 2, 3, 4, 5, 6. Okay. What
4.
about 9?
4.
1, 2, 3, 4. Yeah. So what's the total?
5.
20.
22.
20. Right? Sum of the frequencies here is the sample size, which is 20. Okay. So the next thing is how we calculate the relative
And
frequency.
22.
22. Why?
No, ma'am, 20.
20, sorry.
Yeah. So the next thing is how to calculate relative frequency. The ratio of the frequency to the total number of observation is called the relative frequency. So we have already obtained the frequency for this. So the frequencies are simply 2, 4, 4, 6 and 4. Right? And the total was 20. So now for finding the relative frequency, you have to simply do 2 by 20. Right? What is 2 by 20?
0.1.
1.
What is 4 by 20?
0.5.
0.
0.2, bro.
0.2.
2.
5.
Why so many
0.2.
different answers for this?
0.2.
0.2.
It's 1 by 5, so 0.2.
2 it is.
Okay, and what about 6 by 20?
0.3.
0.3.
Okay, what about 4 by 20?
0.2.
0.2.
See, in this case, luckily here you will see that everything is just a whole, there are no approximations, right? So all these values are exact values. So here we will not have any errors. So what is the sum of all the relative frequencies here?
1.
1.
Yeah, so you can see the sum is 1 exactly, right? But you have to be very careful when you are having some approximate values. In that case, please be careful. The approximate values, the sums should be 1. Okay, so that you have to be very careful. Okay, fine.
Okay.
Here is a quick exercise again. So, a total of 2,000 cases of COVID-19 have been registered on 5th May 2020 in 5 key districts of Maharashtra. The proportion of cases in each district has been listed in table. In this table, you have the list. How many cases were registered in Pune on 5th May? How do you identify that? So you are given the relative frequency. So this is the relative frequency. You know that relative frequency is frequency by n.
Total.
So now here you want to know the f corresponding to. So how many cases were registered in Pune on 5th May? This means what is the f?
400, ma'am.
Yeah, corresponding to Pune. That is the question. So for Pune, you know that it is relative frequency is 0.20. And what is n? N is given as?
2000.
Right? So N is 2000. So what is F here? 400. Right? Is this fine? Okay. Okay, so let's do another exercise. Choose the correct statements from the following. More than one option can be correct. Can you go through and tell me?
C.
Which one?
A.
Only B is incorrect, ma'am. Rest of them are correct.
Okay, so option A, two data set having same frequency distribution will always have same relative frequency. That is obviously
A
true,
and
right?
D.
So this you can see if the
And also correct.
A and D.
Okay, and option B, two statement having the same frequency is just opposite to option A, so incorrect. And what about option C? Two data set having the same relative frequency will always have the
No, ma'am.
same frequency
This is wrong.
Okay.
They have
Yeah, for example, so let us say you have some class 1, class 2, class 3 with relative frequency given as 0.2, 0.2, 0.6. Okay, now you have another relative frequency table with the same relative frequencies. Okay, but here the frequencies are 5, 5 and 15. And here the frequencies are 10, 10 and 30. Is this possible or not? So what is it you observe here? So different frequencies.
But same relative frequency.
Yeah, but same relative frequencies. Okay, is this clear? Because of which option C is not correct, right? So we'll always have same frequency distribution is not correct. Sometimes it is possible, right? Sometimes it is possible. That's why option D is correct. Can have the same frequency distribution. Yes, that is possible, but it is not always true. Okay, so what is the difference between option C and D? Is that clear for everyone?
Yes, ma'am.
Yes.
Sorry, what? Okay. So the next topic here is charts of a categorical data. Okay. All right. So now the two most common displays of categorical variable, they are bar chart and pie chart. Right. So for categorical variables, we usually draw a bar chart or pie chart. First from a frequency table we need, and from that we can do a pie chart or bar chart. So for pie chart, what is the procedure? You need to have the relative frequency. Once you have the relative frequency, how do you find the angle?
Multiply by 360.
Exactly. So multiply the relative frequency by 360. So can you give the angles in this case?
Yes, ma'am.
The first is 36 degree. Second is 72. Third is again adding 72 to previous one. Then 3.
108.
Yeah.
108, ma'am.
108, yeah.
98. Oh, sorry.
Okay.
72.
Sum is
360.
360.
360.
okay. So again, for this case, since we had like exact values, this degrees also are in exact values, and hence the sum 360, we don't have any issues. If we are approximating, again, we have to be very careful that the sum is 360. Okay. Otherwise, we will have errors.
Ma'am, can you please elaborate a little on approximation? Like how does it work?
I guess we have some examples later. We'll
Okay,
see it at that time. Okay.
Okay.
Yeah. So the same is now given as a pie chart here. Okay. So you see that. So this is shoe size 5, 6, 7, 8, 9. So this angle is 36 degrees. For 6, 7 and 9, you see the angles are same. 6, 7 and 9, the angle is
Also for 9.
72. And for 8, you see the angle is the biggest, it is 108. Right? So this is the pie chart for the above frequency table. Okay, fine. Okay, now let's see this problem. The expenditure for the month of October of a manufacturing company is shown in this figure. If 50,000 was spent on shipping, then what was the total expenditure of October? So what is that we need to do? So for shipping, you are given that 50,000 is the amount spent, right? So if 50,000 is the amount spent, what is the corresponding relative frequency? How will you calculate?
2,500, ma'am. 5% of 50,000.
So first of all, here corresponding to shipping, what is the percentage given? 5%. So this means what is the relative frequency? Relative frequency is
0.05.
0.05. Now they are asking what is the total expenditure, right? So relative frequency is frequency by total. So now they are asking us the total. So we have
Oh,
to
my bad.
F
Then,
by RF. So what is the F given? F is given as, this is your F, 50,000.
then
And
10 lakh.
the frequency is 0.05. So in that case, what is your final answer?
10 lakh, 10 lakh. This was actually a question from one of the exercise, ma'am.
Yeah, maybe. So that is possible. I am taking problems from there. Many problems are from there. Okay. So this is the answer. Is this fine?
Yes, ma'am.
Okay.
Ma'am, please tell how to find relative frequency from 5%.
Yeah, because see, the same relative frequency can be also expressed as percentages. For example, here, this is like 10%, this is 20%, this is 20%, this is 30%, 20%. So relative frequency are sometimes in decimal and sometimes in percentage. Okay, so here typically a relative frequency should be in decimal, but sometimes they are also using percentages to express the same. So for finding percentage, you simply multiply with 100 and you get the value. Okay, and the sum of all relative frequency, the percentage you know, it is 100%. Okay, so now using the same logic, now if 5% is your relative frequency, then you have to divide by 100 to get the decimal value. So you got 0.05. Is it fine?
Yes, ma'am.
Okay, fine. Okay, so let's look at another question. Okay, the distribution of grades in statistics class consisting of 80 students is shown by a pie chart here. Okay, so here your N is given as 80. How many students have secured B grade? So here B is this, right? So your B grade, the frequency here is 32.5%. So from here, what is your relative frequency? You have to divide
0.325. 0.325.
Okay. So now
0.325.
if we know the relative frequency, now here how many students have secured B grade? It means we are looking at F corresponding to B.
26.
Yeah. So
26.
here you see for F corresponding to B. So you know RF is F by N. So your F is RF into N. So 0.325 into 80. The answer is 26. Okay, is this clear for everyone?
Yes, ma'am.
Okay.
Yes, ma'am.
Hello, ma'am.
Yes.
Ma'am, please go ahead. Yes, yes.
Sorry?
Ma'am, one figure. Yes, yes. Ma'am, first you divide 32.5 by 100, so it comes relative frequency 0.25.
Not 100
5.
by 1000.
Sorry, what?
Okay. Ma'am, 32.5 how came? How it's come?
As I mentioned, so 32.5, if you divide
No,
by
sorry. 0.325.
yeah, if you divide by 100, you will get 0.325, right? You have to just divide by 100. Okay? Fine.
Okay. Then 0.325 come.
Yeah. This just like we have done it here. So here also we are dividing 5 by 100 to get 0.05.
Okay, ma'am. Because it is in percent.
Yeah.
Okay.
So to convert to percentage from decimal value, you are multiplying by 100. Okay, and if you are converting from percentage to again decimal, you have to divide by 100. That's it. Okay?
Yes, ma'am.
Okay. Okay, so look at this easy question. Pie chart is used to show the proportions of a categorical variable. Is it true?
Yes.
Okay. Pie chart divides a circle into pieces, which is
Yes,
proportional
ma'am.
to
True.
the relative frequency.
ABC.
Yes, V is correct.
Yes, ma'am.
Okay, fine. So these 3 points are the important description about pie chart. Right? Okay, fine. So next, bar chart is much simpler compared to a pie chart. Bar chart displays the distinct values of the qualitative data on a horizontal axis and the relative frequencies of the values on a vertical axis. Right? So for example, these are the frequencies we have. Now, how do you do this bar chart here? So let's say this is 5, this is 6, this is 7, this is 8, and this is 9. And your x-axis here represents the shoe size, right? And your y-axis here represents the frequency. So in this case, so 5, the frequency is 2. For 6, the frequency is 4. Again, 7, the frequency is 4. 8, the frequency is 6. And 9, the frequency is again 4. Right? And then you are usually shading this bar graphs, right? So you don't leave it empty. You either use shades or you use patterns or something like that. You don't just draw these rectangles. You have something inside, some colors, shades or patterns. Yeah. Okay. All right. So this is how you do a bar chart. It is just very straightforward compared to a pie chart, right? Okay. So now look at the next question. A study conducted in the last 10 years show how students choose different streams after completing 10th standard. The outcome of this study is given in this figure. What percentage of students have biology or politics? Remember here, or means
20.
see, if this is B, this is P, we are asking for B union P, right? Or means union, right? So together. So or means we are looking at biology and politics together, right? So biology here is 10% and politics here is again 10%. So biology and politics together should be 20%. So the final answer here is 20%. So why 20%? Is it clear for everyone?
Yes, ma'am. Suppose if they ask
Yes, ma'am.
biology and politics, what is answer, ma'am?
Yes.
So in this case, biology and politics, are there, is it possible that there is any intersection here? We don't have the data, at least in this, from the bar chart, we don't have any such data for intersection, right? So intersection, if we need some other data for answering that. So in that case, not sufficient data, we can say. Okay.
Computer
Okay.
and commerce, we cannot infer from the graph.
Yeah, even computer and commerce, you have the percentages, right? 15%,
Yes.
25% it is there.
So we can then how to find it? Computer and commerce.
Computer, see, and for and you need the data about how many are common in both. That we are not having from the bar chart.
Okay, ma'am. Okay.
So
Thank
for that, you need something like a contingency table, right? So once you have a contingency table, those who are like intersecting in two things, those things we will know. Otherwise, we will not know how many are intersecting or not. So usually from a bar chart, you will not be asked about intersecting data. Okay?
Thank you, ma'am. Thank you.
Okay, fine. All right, so moving to the next part. So Pareto charts are basically bar chart only, just we are sorting them in a specific order. For example, if you look at this example itself, so here, so now you have to first, for a Pareto chart, we are first doing this ordering. So for example, if you are ordering it in this way, 6, 4, so maybe you have to do this entire reordering. So first starting from 6, 4, 4, 4, and 2. So maybe the corresponding sizes are 8. So this we can follow any order 6, 8, 9, and then 5. Okay. So this is how for a Pareto chart you need to change. In that case, how will the corresponding chart will look? So suppose this is 6, this is 4, this is 2. It's not evenly divided. So 4, 4, 4, 2. So this is how a Pareto chart will look like. Okay, so 8, 6, 7, 9, 5. So here for Pareto charts, what is it we are ordering? Mainly we are ordering the frequencies. Okay, Pareto chart, we are ordering the frequencies. So if you look here, when the categories in a bar chart are sorted by frequency, the bar chart is sometimes called a Pareto chart. If the categorical variable is ordinal, then the bar chart must preserve the ordering. Okay. So if you have a categorical variable which is also ordinal, then the bar chart must preserve the ordering. Okay, so that does not mean that only for ordinal data we can do this. Whenever you are having the frequencies, just by arranging the frequency itself, you can do the Pareto chart. So ordinal is just an additional information. Okay, so here, what is the purpose? Based on that, you have to choose the graph. So for example, suppose let us say, let me give a scenario. In that you tell whether a pie chart or bar chart is more suitable. Okay, suppose let us say you are having a company. Okay, and in that company there are several different departments. Okay, and in each department you are getting some revenue. Now the company wants to see like what is the revenue from each department. Okay, so how the total revenue of the company is divided into each of this department. In this case, is a pie chart more suitable or a bar chart more suitable?
Bar chart.
Bar chart.
Bar chart.
Pie chart, ma'am.
Pie chart.
See,
I think pie chart, ma'am.
at the
It's a proportion.
yeah, you are looking at the revenue of the company and you want to see the distribution of this revenue inside the company, right? So you are
Yes.
looking at one whole thing and the parts of it. So in that case, the pie chart is more suitable, right? So compare
chart.
parts of a whole means you have to look at a pie chart. Okay, and suppose let us say you are having one company. For example, you are having something like a Adidas showroom. Okay, now the Adidas showroom, let's say in Chennai itself, there are 4 different showrooms of Adidas. and each of this showroom you have some sales. Okay, now you want to represent the sales of each of these showrooms. Now which chart will you use, a pie chart or a bar chart?
Bar graph. Bar graph.
Right, a bar chart you can use. Okay, fine. Now let us say you are having a list of cricketers. Okay, and the list of cricketers all are, let us say, bowlers. Okay, so the number of wickets each of them have scored over let us say the last 5 matches or something, that data you are having. Now you want to choose one bowler based on the highest number of wickets they have scored. Okay, so in that case, which chart will you choose?
Bar
chart. Bar chart.
A bar chart
because here
or
is
a Pareto
comparison.
chart? Which is more suitable?
Pareto
Bar
chart.
chart.
Pareto chart.
Pareto chart is more suitable, right? You can easily see who has the highest score and all that, right? So sometimes it is more easily visible in a Pareto chart in certain scenarios. So you have to look at the scenario and decide which chart is more suitable. So you have to understand what is the purpose you are doing the chart. Then only you can choose the correct chart for representing the data. Okay, fine.
Excuse me, ma'am.
Yes.
Ma'am, like we saw the cricketers option, the data was nominal, but in our shoe cases, they are primary example. Size of shoes is ordinal somewhere. So, do we have to prioritize ordinality or frequencies?
Only the frequency. For Pareto chart, only the frequency has to be sorted.
Okay.
But in recorded lecture, ma'am says that ordinal, in case of ordinal, we must avoid it for ordinal.
Sorry, what? What is your question?
In recorded session, ma'am says that we have to prioritize to ordinality.
So you have to prioritize the ordinal order of the data. That what you are saying?
Yes, ma'am.
See, this is the exact line I have mentioned here also. If the categorical variable is ordinal, then the bar chart must preserve the ordering. For example, in this case, okay, in this case, so here it's better if I want to see how many numbers are sold per shoe size, it's better to order it based on the shoe sizes. This is an ordinal data, right? So this is what I can do. But suppose I want to know which shoe sizes are more frequently sold. It depends on the purpose again. So then the data you can choose a Pareto chart. But whenever you have an ordinal data, so this is more suitable, following the order of this. But for a Pareto chart, okay, for a Pareto chart, even if the data is ordinal, if you are deciding to make a Pareto chart, then you have to sort based on frequency. Okay?
Ma'am, it's totally depend upon what's our purpose.
Exactly. Okay? Fine.
Yes.
Okay. So now go through this exercise and see what is the correct answer.
Number B.
This is something very similar to the example of the Adidas one I told you, right? So B.
B
Okay,
is
you can also do a vertical, the same thing you can do, and this also, both B and C are possible. Okay, so A is not true. And for D, it is mentioned that a bar chart with the minimum revenue as a baseline. Can we do that? What should be the baseline?
0.
Zero. Should be 0. Right? So hence this is not correct. Okay, fine. Let's look at another question. A poll was conducted by IMDb to rank 200 movies released in 2019 based on the revenue collected. Okay. Now, which graph is best suited to represent this data?
Pareto chart.
Pareto chart.
We are now looking at the ranks of these 200 movies. So obviously, which is having the highest rank. So in that order, if we have, the graph is more suitable, right? Okay. Okay, so labeling is again an important part. For example, here you see that. So you see the labels are there, right? And here also you see this kind of a labels are important, right? And what are these called? They are called,
Legends.
right? So for pie charts, you need legends, right? And this is a title. So these things are important for a graph, right? So labeling the data is very important, right? You have to name the bars, name the slices in a pie chart, right? And label your chart to show the categories and indicate whether some have been combined or omitted. Okay, so what is mean by this part? Whether some have been combined or omitted. Suppose let us say you are going to represent people of certain income groups. Okay, so let us say people who are having a yearly income of less than 1 lakh. Okay, 1 lakh to 5 lakh, and then 5 lakh to 10 lakh, and then above 10 lakh. So this above 10 lakh, I am combining some data here, right? So in that case, this above 10 lakh, you have to mention that all the data. So it is obvious in this case. Sometimes if it is not obvious, you have to make sure that it is mentioned very clearly. Okay. So here, whatever is above 10 lakh, I'm going to combine. Suppose, so this combining things are usually done when they are having less significance. So for example, let us say that 10 lakh to 20 lakh, there are only two, and 20 lakh to 30 lakh, there is only one. So it is not going to make any significant difference if I am going to write above 10 lakh as 3. It's not going to make any significant difference, and hence I can combine them. But if it is going to make a significant difference, then I have to I should not combine it. Okay. And at last, you see that if you have omitted some of the cases, make sure the label of the plot defines the collection that is summarized. Okay. So for example, now here you see, okay, so this is just the graphs and with the labels you have here. If you have omitted some of the cases, then also that has to be mentioned. Okay. So instead of that particular thing, so what has been included or why we have left that, those things we have to make sure to express it in the graph. Okay, so now let's look at this exercise. Identify the wrong statement. Bar chart is a better tool to describe GDP growth rate of India from 2019 to 2020. Is it true?
Wrong. No.
Yes,
Wrong.
wrong statement.
Yes, wrong. True.
This is actually correct.
Correct, ma'am. Correct.
Pie chart is not effective when we have large number of categories. Is that true?
True.
This is also correct.
True, ma'am.
And what about
C
Pareto
option is
chart?
wrong, ma'am.
Only for one
C option is
False.
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 right? Okay, bar chart is better than pie chart if we want to compare the actual counts.
true.
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 Yeah.
Fine.
Yeah.
Okay, now let's look at this exercise.
Could you please explain option A? Okay.
This one.
Yes, ma'am.
So here option A is very straightforward. So here you are having all the different data from 2009 to 2020. Right? You are having all these different data values. Okay. So now bar chart is a better tool to describe the GDP growth rate. So whatever is the growth rate in each year, okay? So what is the growth rate in each year? So bar chart is better, right? You cannot use definitely pie chart, right? Pie chart means what will happen. So only when you have something as a whole and then you are looking at the division inside, then you can use pie chart. But here nothing as a whole we are seeing. Every year, what is the GDP? That's all we are seeing. That's why a bar chart is more suitable here. Is that fine?
Yes.
Yeah. And this you see, this is an ordinal data and hence we are following this order only. Okay.
Yes.
Okay. So now let's look at the next question. Go through the complete question once and then try to answer. Don't be in a hurry.
There are no legends, ma'am.
Exactly.
Ma'am, B option.
B option.
So here a subtitle and all, you have a title. So no subtitle is required. And no slice has an offset from the center. What is mean by offset from center?
Ma'am, this means that ones get moved from the center.
Yeah, I guess there was some image. Yeah. So for example, you see, sorry, in item C here, so this is an offset.
Ma'am, offset.
Yeah, so from center it is kind of protruding outside to show the importance of this. So that is an offset, which is not the case here. So there is no offset here. Okay, which
Ma'am,
is,
there is no legend which represent blue, green, yellow, and red.
sorry, what?
Ma'am, there are no title which represent blue, green, yellow, and red.
That is
Inside.
why we have mentioned option B is the problem because legends are missing. So what is blue, what is green, what is, so that is what is legend, right? So what is this blue for? And what is this green is for? Right? That is what is called legends. Yellow. Right? So these are the legends. What is that is missing here. Okay. Okay. So the next thing is area principle. What is area principle? The area principle here says that display of data must obey a fundamental rule called the area principle. What is that? The area principle says that area occupied by part of the graph should correspond to the amount of data it represents. What does it mean? Suppose let us say, so here you are having a circle. Okay. Now exactly I am considering this much. Okay. In this circle, what is the area this is representing? This part is representing.
25%.
Exactly. Right. So you see that this part, what's happening? This part here, this is 25% of the circle. Okay. So suppose let us say some category. So any category represented by this sector or represented by this part should be 25% of the data. So do you understand what is meant by area principle now? So whatever is the graph, in that graph, what is the percentage of that particular area representing? That should be the area. That area is the percentage of the data which is represented by that part. Is that clear what is meant by area principle? Okay.
Ma'am, can we apply this to bar graph also? How
Yes.
to explain
Yes.
in bar graph, ma'am?
Yes, for bar graph also it is applicable, right? I have some examples there, you can understand it better. So
So,
here,
ma'am,
yeah.
where you have drawn the rough figure and shaded with yellow color. So this is the area principle, na, ma'am.
Sorry, what? Can you please repeat?
Ma'am, the diagram you draw rough, okay?
Yeah.
And the part you shaded yellow. So the yellow shaded part is a ma'am area principle, na ma'am.
So I am applying area principle is applicable for each and every category of the data. So here just for an explanation, I am using this yellow part, but this has to be applicable for each and every part. For example, you look at this graph. So here this 42%, 11%, 42%, 5%, everything should, each of this part should represent the corresponding percentage of the data and percentage of the graph. Both should match for each part. Okay.
So ma'am, basically what is area principle?
See, it means
Pretty
that,
confused.
yeah, I'll repeat, no problem. So 42% of this circle is exactly violet color. Violet or purple, what do you call it? Let's call it violet, okay? So
Yes,
of
ma'am.
this circle, 42% is exactly violet. And item D is 42% of the entire data.
Ma'am,
Percent of entire data.
item D is occupied 42% of entire data. So
Exactly.
this is area principle.
Exactly. So whatever, so here this is item D, right? So if item D is represented in this part, whatever is the part of this data in the entire data set, that should be the area of that part in the representation as well. Is that clear now?
Ma'am,
What?
it means that 42 repeated to 42% repeat 2 times.
Yeah, so it means that again 42% of this circle. So you have the circle is now divided into 4 parts. So 142% is exactly item representing item D. Another 42% is representing item B. And another 11% is representing item A and 5% is item C.
So
Okay.
42% is my area
Ma'am,
principle.
as like in our table, a phone occupied some space, so that space is called area principle.
What is called area principle?
Ma'am, like in our table, some space occupied by our mobile phone. So that space which occupied by phone is area principle.
No. That is, see, the area principle is applicable for charts. Mainly here we are talking about pie chart or bar chart or something like that, right?
So
So
ma'am,
here, yeah,
here 42% is the area principle, na ma'am.
yeah.
Because first half is 42, then second half is also 42.
See, the thing is that it is not about how many times it is repeating, but what is this? So far, I'm saying that item D in this chart, I have mentioned it is 42%. So in that case, I should make sure that this 42%, whatever is mentioned here, is the area in this circle as well as the percentage of item D in the entire data. Both should match. That's all. Okay. So if you calculate the area of this sector, that should match with the percentage of the data representing this sector. That's all.
Okay.
Clear?
Ma'am,
Can we say like if the area of a circle is said to be representing a certain value in a data, that would be the percentage of the representation in that pie chart.
Yeah. So maybe if I put it in this word, so let us say your entire area of pie chart is 100%. Okay. So now this 100% is divided into different parts, right? So this, for example, 42, 11, 5 and 42. Okay. So now this entire chart, you first see what is the area occupied and then compare the percentages with the percentage of the data representing that particular part. Is it clear now?
Yes, ma'am.
Yes,
Oh.
ma'am. Yes, ma'am.
Oh.
ma'am,
Yes.
why does this area principle looks like a side effect of calculation that we do instead of actual principle that leads the calculation?
It is not a side effect. It is a direct effect of the representation of the frequency table. Okay, so whatever we are in the frequency table, what we are doing in the frequency table, we are dividing the entire group into smaller groups, right? The frequency table, what is that we are doing? Each part. So this is the total. The total is divided into smaller groups, right? And these smaller groups, now each of this is represented separately in a bar graph. So a bar graph or a pie chart. Now each of this if you are representing in a pie chart, now this is one sector, this is another sector. You see the biggest sector corresponds to 6, right? We have already seen that also, right? Where was it? Yeah. The biggest sector corresponds to 6. It is a direct effect of the frequency table. Whatever calculations we are doing, it is a direct effect of it. Okay, so if you are calculating what is this percentage of this green color in this circle, that will exactly match with this percentage, relative frequency percentage.
Got it, ma'am.
Okay, fine. Okay, so where were we? Okay, so now you look at this graph below, this pie chart. The left-hand side, you see item C is actually only 5%. The green color should be actually 5%. And item A is actually 11%. But when you are doing this offset, what is it you see? When you are doing this offset, it looks like item C is occupying a bigger area compared to item A, which is not true when we are comparing the actual percentage of the data. That's why the left hand side figure is violating the area principle. Why left hand side figure is violating the area principle? Is that clear?
Yes, ma'am.
Okay. Similarly, you can see it in this bar chart. So the left hand side bar chart, what is that you see? The first chart is 108.6 million. And the right bar, the next bar is just 101.7 million, right? So in that case, so this part is like approximately half, this representing, right? Suppose this is some 100%. So this looks like half of it, right? The area, if you see this area, if you compare it with this area, it looks like it is 50% of this. But the values are not matching with it. 101.7 million is definitely not half of 108.6 million, right? So this representation is definitely not correct. Do you understand what's the problem here?
Yes, ma'am.
Yeah. So you see this is not a correct graph.
Yes, ma'am.
So not obeying area principle. Okay. But here on the right hand side, this is the actual graph, right? This is how it should look like. You can also see it is matching with these values here. So you can see that this is the correct way of representing the values. Okay, so here it looks like this part alone, they kind of zoomed in. That's why it is looking like this. Okay, fine. Okay, so other kind of errors which can occur in graphs is the truncation errors. So the truncation error, again here you see that. So here what they did, instead of starting from 0, they started from 75. Okay, so because of which you see the west and east region, the distribution looks very low. So the depiction from the left hand side is making us to feel that west and east the distribution is very low. But if you look at the actual graph where there is no truncation, we don't see that it that way, right? It looks like there is some dip in west and east, but not very much low compared to south and north, right? Yeah.
Yes.
So this is what is called truncation error. So here, because of this graph is truncated in the 0 line, so you see this difference. This is another error here. Okay. And indicating the braking is again very important. Where you are indicating the brake is again important. So here you see that everything here stops at 400. This x1, x2, x3, this is stopping at 400. Only this last x4 is crossing 1400. So there is no point of just keep on drawing all the points right from 0 to 1400. You can do a break here in between and then continue, which is not going to affect the data at all. We can anyway see that this break is already mentioned clearly. And also you can see clearly that this is 1400. So this is how you have to indicate breaks whenever there is a break. Okay, the break should not affect the other data values. It should also be clearly mentioned in the graph. Okay, so this is
Can we have a break in the x-axis also? I
In
mean,
the
if there are numbers represented.
x-axis, if you are having break, then it means you are not representing many data there. So usually a break in x-axis is not many people do. If you are doing a horizontal bar, so this is our vertical bars. If you are doing a horizontal bar, then it's fine. Otherwise, usually breaks in x-axis is not something commonly seen.
Okay, ma'am.
Yeah. Okay, so here is a small exercise. Can you all go through this?
Missing baseline.
Yeah.
Option D.
Okay, so you see
And
that
y-axis is option D.
baseline is missing. What else?
Manipulated
y-axis.
What is meant by manipulated y-axis? See, when you look at this graph, the impression is that the scores are all very low. If you don't look at the y-axis marks, if you don't know what is the total marks, that it is out of 100, if you don't know that, the graph will give an impression that the scores of these students are very low. But the actual graph just stops somewhere here. Right? These are just extra. Right? This part is not at all necessary. Right? Because the total is just out of 100. So why you need up to 200 here? Right? So this is a manipulated y-axis, and hence you see that it is a misleading graph.
Yes.
I'm sorry, ma'am. What is missing baseline, ma'am?
Missing baseline means here it is not starting from 0.
Start with 0.
Okay, ma'am. Thank you.
Yeah.
Ma'am, is it okay if the y-axis does not occur at proper intervals?
Usually y-axis, if we have equal breaks, that is what is usually recommended. Okay, having unequal units is not a common way of practice. Okay.
Okay.
Yeah, and round off errors is what I told you in the very beginning. So someone also asked, what is this round off errors? What is this approximation errors? So here we are. So now,
दस बीस तीस चालीस पचास साठ सत्तर अस्सी नब्बे
sorry.
20.
Are you saying something? Someone is saying something? Okay. So now it is very important to check round off errors. What is mean by round off
Ma'am,
error?
the total percent, it's not total 100%.
Exactly. Right. So for example, suppose let us say you have some frequencies like this. So let us say you have like frequency is like 3, 3, 4, 5. So here, how much is there? 9 and then 15 is there. So let's say you have another 2 and 1 and 2. So what's the total here? What is the total here?
20.
20. So what are the relative frequency? Can you all take your calculators and check? What is 3 by 20? Again, here we are getting just whole numbers, I guess. So this may not be a very good example to show approximation error.
0.15.
0.15.
Yeah, but I guess this example will not be very suitable. Maybe I'll make this as 2. Okay, so if I'm making this as 2, then this is 21. So in this case, what is this relative frequency?
Ma'am, 0.148571.
So approximated, if I'm taking, it will be 0.148571. 14.
14.
3.
So this is again 0.14. What about the next one? What is 4 divided by 21? So again 0.19.
Ma'am,
Right?
0.19.
Okay. What about 5 divided by 21?
Ma'am, 0.23.
23 or 24?
23. 23, ma'am. 24.
Yeah. So what
Ma'am,
is
23 it is.
See, if it is 238, anything more than 5 means you approximate it with 0.24, right? That is the usual way
Okay,
of
ma'am.
rounding off.
Okay,
Okay.
okay.
Okay. And for 2 divided by 21?
0.09.
Ma'am,
0.095.
0.952. 0.0952.
So 0.95 is there. So since 5 is there, if I'm adding 1, it will become 0.10, right?
Ma'am,
So
how
if
are
it,
you rounding
if
off
it
means
is,
adding
so
5?
yeah, this 5, anything above 5. Above 5 means I should add 1 here.
Okay, ma'am. So, ma'am, I want to ask that if I not do this thing by rounding off, so my answer may be wrong.
See, this is the standard. Usually in exams, we are giving range because students may do this kind of errors. So we allow for a range of values. Okay, so that should not be a problem in exams. But what is the usual procedure for round off? You should know at this stage, at this level. Definitely, this is the way to round off. That you should know definitely. Okay, so how you are rounding off, is this clear for you?
Yes, ma'am.
Some bit clear, bit clear.
I'll ask few examples. Let's see whether you have understood. For example, let us say you have 2.3456. I want to round off to 3 decimal places. How do you round off to 3 decimal places?
2.346.
Okay. If you want to round off to 2 decimal places, how do you round off?
2.35.
Okay. Round off to 1 decimal value.
2.3.
0.3.
2.
Is it clear?
If,
How do
Ma'am,
you?
yeah, please explain.
Sorry?
where the
Ma'am, please explain.
situation,
Explain here how you do it. How you did, ma'am, because
How are we doing? So here, for 3 decimal, you have to look at the 4th decimal. Is it above 5? 5 or above?
yes, ma'am.
Then you
Above.
then you add 1 here. Add 1. Okay. And for 2 decimal values, you see the 3rd decimal. Is it 5 or above?
Yes, ma'am.
So you add plus 1 here. Okay. And for 1 decimal value, you see is it 5 or above?
No, ma'am.
It's not 5 or above, so no change. Is it clear?
Yes, ma'am.
Okay, so this is how we do the usual round off. Okay, now
Okay.
here we have calculated the relative frequencies. Can you all find what is the sum of all these relative frequencies?
1.01, ma'am.
Exactly. So you are not getting 1.00. Exact one you are not getting. You are getting 1.01. Okay, so this is what you called as a round off error. So how to avoid this round off error? Maybe you have to adjust it somewhere. Maybe you can adjust it here. So adjust it here maybe. So this kind of adjustments we have to do. So you cannot do it randomly. You have to choose the appropriate place because this is something we truncated, right? 0.23 something was there and we truncated it as 0.24. That's why I'm choosing this. So you have to choose the appropriate place and make sure that the sum is 1. Right? So if this kind of errors are coming, so what will happen to the corresponding pie chart? For example, look at this pie chart. These are the percentages here. Now again, when you are multiplying with 360, again there will be more errors. Again, you will do more, some more approximation when you are doing multiplying with 360. Right? So there again some more errors will add up, resulting in something like this. What has happened here? What is the sum of all sum of all the percentages here? Can you calculate and tell me?
101%.
Sorry, how much?
101%.
Okay, so you are getting 1 or 2, correct? Is this correct? Yeah?
101.
1 0?
101.
101. Okay.
101%.
Okay. So here you see that this is not correct. This is because of round off errors. Okay. So this is what we have to be very careful. So based on this, can you try to answer this question?
A.
Why A?
B.
B, ma'am.
Why B?
Ma'am,
Because
B,
some is not
because
Sum is
it
not
is
100.
not 100%.
Ma'am, A is
B, yes.
because it is not 100%.
So
I'm not
some,
following the area principle correctly.
right? So see, area principle is not about that. Area principle is that, so for example, here if you see, this is 25%. So a little bit more than that, 35%. And little bit less than, so in this case, if you see a little bit less than this, it is 22%. And here this part, if you see, so little bit more than 25. So this is together, it is occupying 26, that's fine. So more or less this area principle, we don't have a problem. But the problem here is sum is not 100. That is a problem. It is not about the area principle. The problem is with the sum. The sum is not the problem.
Some is coming 102, which is not equal to 100.
Yeah, so it is sum is 1 or 2 here. So that's the problem because of which we are having it here. Okay, fine. Okay.
Yes, ma'am.
Okay, ma'am.
Okay, so the next part is summarizing categorical data. So we have different measures of central tendency to summarize the categorical data. You know that mode is the most common category, which has the highest frequency. Okay, so here, for example, if you look at this bar chart, what is the mode?
Blueberry.
Blueberry.
Blueberry 40.
Okay, and if you look at the pie chart, what is the mode?
Painting.
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 Okay. So sometimes the data can be bimodal or multimodal also. In this case, what are the modes? How many
Football
modes
and
are
volleyball.
Football and volleyball.
Or volleyball.
there? Okay. And what about median? So median is possible only for ordinal data. For nominal data, we cannot do median because for finding medians, we first have to order the data, right? So for example, here you have this survey. Can you all first arrange them in order? So what is the, so let us say that from very poor to good, if you are categorizing them, if you are arranging them. So what is the lowest rating here?
Poor.
Very poor.
So how many very poor?
Very poor.
How many very poor are there? Only
Poor.
one.
One.
Okay.
One,
And then how many poor are there? 1, 2,
3,
3, ma'am.
3,
4, 4, 4.
4.
Sorry, ma'am. 3
Okay.
only, ma'am.
Okay. After poor, you have fair. So let's say
2 fast, ma'am.
Two goods.
okay. And after fair, we have good. How many good? 1,
Two.
5.
and then you have
5.
2,
4 very good.
3, 4. Very good.
5, ma'am.
5 or 4. 4 only I see.
3 very good.
Only.
3, 4.
Okay.
5, ma'am. 5. Sorry, 4 only 4.
And then last is excellent.
Excellent. Only.
Okay, so 13, do we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13? Yes. Okay, So now if n equal to 13 is odd, the median position is n plus 1 by 2. So what is n plus 1 by 2?
Good.
7, ma'am.
7, right? You look at the order. So let's say 1, 2, 3, 4, 5, 6, 7. So that is your median. Okay. And now in this case, again, we have to arrange the data. Can you arrange the data? So do we have any very poor? We don't have any very
No,
poor.
ma'am.
Okay, so we have poor 1, 2. We have poor. Okay, and then we have fair 1, 2, 3.
P3.
Okay, and then good we have 1, 2, 3, 4.
4.
Good, 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 good. And then we have
2.
1, 2. Very good. And then excellent.
Excellent.
So let's just check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, we have everything covered. Now your n is 12. So 12 by 2, 12 by 2 plus 1. So 6, 7. What is there in 6, 7? 1, 2, 3, 4, 5, 6, 7. Okay, so this is your median. If they are different, then you have to consider both. Okay.
Okay, ma'am.
Okay. Now, which of the following can be defined for both nominal and ordinal data?
Mode.
Mode. Mode.
Why not median?
Ma'am, in
Median is not
nominal
defined
there
for
is no
nominal
order.
data
Because we can't perform
since we have to arrange them.
mathematical operation
Want
on nominal
order
or ordinal data,
nominal
static
What
data.
quantified
about
data.
mean? What about mean?
Ma'am, mean also not. Because ma'am,
It's
we
only
cannot
for
perform
numerical.
mathematical application.
Okay, fine.
Arithmetic operation can't be operate on ordinal data.
Okay, fine. What about this one?
Mode.
Median.
Mode.
Oh, sorry, mode.
Right? Okay.
I guess mean.
Mode.
Yeah, that's it, I guess. So we are
Why it will be
done.
mode?
Why mode? So here, see, we are just
Maximize.
having the now maximum sold brand. So in order to what is the purpose here? The purpose is he wants to maximize his her profit on sales. So she has to increase her sales. So she has to see the demand. Which one is having highest demand? The one which has highest frequency sales, right? So based on that, the profit is made, right? So the brand with highest frequency is the mode, and hence we are choosing the mode. Okay.
Ma'am, for previous question, why this mode?
Sorry, what?
For the previous question, why this mode, ma'am?
For previous question, I guess everyone actually answered this. For nominal data, we cannot compute mean and median. That's why only mode. Okay. For
Okay, ma'am.
computing mean and median, we need, for mean, we need a numerical data, and for median, we need ordinal data. Okay. Only mode can be computed for nominal as well as ordinal data. Okay. So we have covered everything from week 1 and 2. So from week 1, mainly what are the different topics we have? We see what are descriptive statistics, what are inferential statistics, population, sample, and then we see the different categories of data, categorical, numerical, and further classification as levels of measurement, nominal, ordinal, interval, and ratio, right? And then we have what is time series data and what is cross-sectional data. There is something I missed here. I guess it is structured and unstructured data I missed here. So maybe quickly I will tell what is structured and unstructured data with some examples. So usually structured data are things which can be represented in a table, and unstructured data are things which we cannot easily represent in a table. For example, suppose I am having all the YouTube comments. Is it structured or unstructured?
Unstructured.
Unstructured, ma'am.
Structured. Okay. And suppose I am having all the
Email ID also.
number of likes and number of subscribers, something. So this kind of data I'm having. So is it structured or unstructured?
Structured.
Okay, fine. Suppose I'm having all audio messages. Is it structured or unstructured?
Unstructured.
Unstructured. Okay, so I guess you all know what are structured and unstructured data. So these are the things we see in week 1, and then in week 2.
Hello, ma'am.
Yes.
Ma'am, how videos and number of likes, number of subscribers are structured data?
So because we can easily put them in a table, right? So whatever is the name of the video title you put, and then you put number of likes, and then you put number of subscribers. It can be easily represented
Okay,
in a
ma'am,
table.
understood. Now understood.
Yeah. Okay. And in week 2, we start with frequency tables, right? So in frequency table, yeah, so we start with frequency table and relative frequency table. And then to represent them using charts, we have pie chart, bar chart, and Pareto chart. And then what are the best practices and misleading graphs? So for that, you see how to label the given chart, and then how to deal with multiple categories, area principle, and then misleading graphs. So in misleading graphs, so you see the truncation error can happen, truncation error, or you can see manipulated y-axis, right? And then round off errors are also possible. That is what I mentioned as truncation error or missing. Yeah, that is sometimes it can be different. Yeah, missing baseline is a good point. Round off error. So these are the different ways in which a graph can be misleading. Okay, fine. And then you see the descriptive measures. So for categorical data, only mode and median are possible for categorical data. So in week 2, we are looking at only categorical data and hence only mode and median. Okay. All right. I just have a general suggestion to everyone. See, at least till week 4, it is usually in most of the courses, week 1 to 4, the topics are very easy compared to the other upcoming topics. In Stats 1, to my knowledge, till week 8, everything is easy. But comparing to week 5 to 8, week 1 to 4 is even easier. Okay, so I really recommend that for quiz 1, try to score your maximum because this is the topic where you can easily score. Okay, so I really recommend all of you to concentrate on scoring your maximum in quiz 1. Okay, definitely you should do this for other exams also, but I'm saying quiz 1 is much easier, so don't miss any marks here. Okay, so I wish you all the best for your exam. So hope to see you after quiz. Probably the second revision session I will not handle most probably. If I handle again, we'll meet. Otherwise, we'll meet after the exams. Okay.
Ma'am, can you give the PDF?
Thank you, ma'am. Ma'am, also,
Thank you.
can I get the drive link for the previous notes, ma'am, week 2 and week 3?
It is there in the supplementary
No,
contents.
ma'am, supplementary, only week 1 is available.
Week 1 and 3 are available. So week 1 and 3 I handled. So those notes are available, I guess.
Ma'am, no, ma'am, week 3 also
Excuse me,
not there,
ma'am.
ma'am.
Are you sure?
Yes, ma'am.
Checked, it was only week 1.
Just give me a minute.
My mock test is graded.
Let me check the drive link. Just a minute. I shared it last session also. Anyway, I'll share it now. Just give me a minute. I'll also add this particular notes.
Excuse me, ma'am.
Yes.
Ma'am, could you please share all the links that you shared last time? I wasn't able to attend the session. And the email
Okay.
ID also.
What you want me to share?
Ma'am, you shared some of the links last time, in week 3 summary session.
I'm sharing the drive link here. Please have a look.
Okay, ma'am.
Ma'am, and also there are some 2 more questions available in one of the weeks. When I went through the lecture content, so do we have to study that also for the computer-based test, or it will only be MCQs?
So computer based test, it will be MCQ, MSQ, or numerical type answer only. Okay, I have
Thank you,
shared the
ma'am.
drive link containing my notes. I will add this notes also here. Just
Ma'am, there is
yes.
another section that got recently added called Commandments of Stats. Would there be any questions on that?
What? Sorry, what section?
Commandments of Statistics is something that got added in the dashboard. Would there be any questions to that?
Where it was added?
In the course, stats course.
What was added? 9 commandments.
Yeah.
No. So that is just guidelines kind of things. So how to study. So just like I mentioned some suggestions, right? So they are something like that only.
Okay. Like nobody taught us anything about it. Nobody said anything about it. So just
They're
ask.
just some guidelines for doing the course in the best way. Okay. Okay.
Yeah.
So I'm
Where is
uploading.
it available, ma'am?
Excuse me, ma'am.
I guess it is there in the course introduction page or something. Just a minute, I'm adding this notes in the drive. Please check if it is visible. Okay.
Ma'am, our
Ma'am, could you
weekly
please share your
mocks
email
are
ID also?
Sorry, what?
Ma'am, could you please share your email ID also?
Yeah, I can give.
But count पे जो represent कर रहा है count 1 minus count 2 इसके
Yeah, are there any other questions?
Yes, ma'am.
Yes,
Yeah.
ma'am.
Yeah.
Weekly mock
Ma'am.
test
Yeah.
is graded.
Tell
If
me.
it is graded, it can affect on qualify exam.
Sorry, I really cannot hear you properly.
Ma'am, can you give example for descriptive statistics and inferential statistics, ma'am?
I have given several examples in the week 1 live session.
Ma'am actually is asking about ma'am actually is asking about is weekly mock test is graded.
No, I guess just for some eligibility criteria, this mocks are used, but the exact grades are not used. If you submit, that should make sense. It is for some eligibility, it is required, I guess.
Ma'am, are these notes available on the portal?
There is mentioned graded
It should
for
be
the week 1 and week
available,
2.
but you are saying some of you are saying only one thing is available. I'll make sure the other two are also added here.
Yes, ma'am, only week 1.
Yeah, I'll tell the ops team to add the other two also. I have already shared this drive with them. I'll tell them to update.
Yes, ma'am.
Ma'am.
Yes, ma'am. I have one more doubt.
Yeah.
But in dashboard showing it is graded.
I guess that is how the format sometimes is confusing for me also. The term that is how they are using graded means sometimes they have to use the word graded for considering it for what did I say? For some qualification. What is that I mentioned? I just told it just before. For eligibility, yeah, for eligibility also sometimes if it is graded, they will call it as graded. But usually, yeah. So this is used for eligibility only, I guess. Okay.
And ma'am for also for the practice of for your quiz 1, no ma'am.
Ma'am, with the email ID which you sent me for why?
Will I be adding what?
Email ID sent by you for which
Yeah.
purpose?
Someone asked my mail ID. I don't know what is the purpose. Maybe they have some specific thing to write to me. That's why I shared.
Ma'am, also the IITB is officially they have given some notes. Can we learn for the exam that those notes
Yes,
that will
yes.
be
If you have,
sufficient?
see, there is nothing called sufficient. So usually, what is the recommended thing is that, so if you are able to answer all the assignment questions by yourself, if you are able to understand the concepts taught in the lectures clearly, that should help you to score very good marks in the final exam. This is the usual assumption. So it is
Okay.
completely based on the student. So suppose let us say the student is able to correlate few things here and there and able to think and answer all the questions, then that is fine. But some students don't have enough practice or they get tensed in the exam, so they won't be able to correlate things. So for some questions, it is not just from one topic. Maybe 2, 3 topics are together in one question. So in that place, you have to think a bit, right?
Okay.
Outside the box. So what is mean by is it enough or not? It is completely based on you. So the recommendation is this. So if you are
Okay.
able to solve all the questions on your own, then that should, and also if you are able to have a clear understanding about the topics discussed in the lecture, then that is a decent framework to score good marks. Okay.
Thank you.
Ma'am, can you
Ma'am,
please have a session of like rapid fire question types like for practice?
A session for rapid questions.
Yeah, ma'am, for practice, it's really nice if we just practice some
Okay,
good questions.
I don't think I will have enough time to do that. Maybe I'll ask the TAs to prepare something like that. Okay.
Thank you, ma'am.
ma'am, I have one question.
Yeah.
Ma'am, are qualifier marks carried in our next term?
What is credited in next term?
Ma'am, it marks credit will carry in next term.
He means that will it be added to our CG or SG type?
So you are asking whether these marks are carried over. Is it kind of a CGPA cumulative thing will happen or not? You are asking, right?
Yes, ma'am.
Yes, ma'am.
I guess GPA and CGPA are two different parts of your mark sheets. GPA is different and CGPA is different. So over the term, CGPA will get builded up, but I have to confirm it with the grading policy. I have to check that whether cumulative thing is there or not. I have to confirm. Maybe you can write to support and check this. I'm not sure.
Ma'am, the qualifier exam and quiz one is same.
For quiz one, you have qualifier exam. Yes. Okay, so those who
Excuse me,
are
ma'am.
in qualifier, yes.
Ma'am, suppose we have cleared the exam and we are in week 5. So like we will have to compulsory study all these 4 subjects, or we will able to choose like which subject we want to study or something.
I don't understand. Sorry, what?
Ma'am, actually, I'm saying, suppose we have cleared the exams and now we are in week 5. So in week 5, we will have to study these all 4 subjects, stats and CET
Oh,
English,
okay.
and it's compulsory, or we will have the choice of choosing the subject.
So you have to definitely, if you have to move to the next level, so once you have to complete foundation level course, you have to complete all the courses, but you have the option to choose which one you want to complete first and which one to do later. That option you have, but you have to complete all the courses.
Okay.
Okay.
And we have lots of tutorials alongside with lectures. So are those considered for in-person qualifier exam?
As I told you, if you are able to understand all the concepts given in the lecture and if you are able to solve all the assignment problems, activity, practice, GA, if you are able to solve everything on your own, then that should give a decent marks in your final exams. See, you have like thousands of resources available for you for preparing for one exam, but it is not possible to go through all the 1,000 resources. What is the primary source you should be thorough with? These are the primary sources. All the lecture notes that you should have a very clear understanding and all the assignments. That you should have a very clear understanding. These are the primary source. Apart from that, whatever is there, it is good if you can go through. That's all. Okay.
Thank you.
Okay, ma'am.
All right then. So see you again later then. Thank you all.
Thank you, ma'am. Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
He has left.
Thank you, ma'am.